You're all intelligent young people. You all recognize that when you knew how to add, you knew how to subtract. You all recognized that multiplying followed the same rules that you already know. So what is the logical assumption to the problem of dividing radicals?
It's like dividing variables. So
logically, if I had 15x squared over 5x, what is the answer? 3x. Because you do 15 divided by 5 and x squared divided by x. Right? Now, when we multiplied 5 root, I shouldn't use red because I just wrote in red there. 5 root 2 times 3 root 3, you got 5 times 2 root 2 times 3. Yes? So logically, using your brains, if you just multiplied the radicands here, what should you do with the radicands here? Right. So what is this answer? Root 6. Yeah? Yeah. Is your little x missing here like mine is? How frustrating.
do you guys love 15 to the power of 3?
That's my favorite number, actually.
Yes, 15.
So,
15 multiplied.
again, logically, in your head, you could all do this question. But we're not going to do it in our heads. We're actually going to write it out. This is, and I will use highlighting to help, this is 15 divided by 3. Und den a root of 15 divided by 3. Und den an x cubed divided by x. Und den y squared divided by y. So our final answer is 5 root 5 for the yellow, and then x squared, and then y, and then
What is that again?
There's so many colors.
what do you see there? So what's going here? So my final answer is 5x root 5y.
Hey, those are the colors of the tropical skittles. Because I specifically remember thinking. I specifically remember the pink one.
Is everybody good?
That's why I buy this up.
So, if I were to give you this, 9 root 18 over 6 root 3. What would you tell me is the answer?
No, you don't. I wrote down 3
Remember, you must bring all previous math knowledge to the party. Hasn't.
You have to make them mixed, or, yeah? No, you have to make them entire.
I mean, I'm not trying to put you down, but that was really unexpected. And then as soon as they looked at you, which is it? Is it this? Or is it this? I'll assume it's this.
9 times 3.
Oh, who said 1.5?
47.
What do I want to do to all decimals? Crush them, because they are evil and for the weak-minded.
That's what we use in currency. You never see $3.
That doesn't work either.
Anybody who runs their life by money is weak-minded.
I run my life by fractions.
What is the answer? 3 root 6 over 2. Or 3 halves root 6. Just like the example, the numbers work together. 9/6 is 3 halves. And the radicands work together. 18 and 3 is 6. All right? All right. Now, it seems simple, right? Just divide, no problem. Easy peasy lemon squeezy. Except in this case, not like multiplying, but in this case, there's an extra wrinkle. And the wrinkle is this. In radicals, all right, what math is that? No, fractions aren't a math, Roman. What math is happening there? Division. Excellent. Now, that is also a rational number, yes? And in a rational number, we know that x and y have to be integers, and y cannot equal 0, yes?
Yes.
Okay. If y is an integer, is it allowed to have any decimals? No, because integers have no decimals, right? So, yes, you can, but it's not an integer. That's a rational number. Now, knowing that integers cannot have any decimals, tell me if what I am about to write would be allowed. 1 over root 2. Does that make any kind of sense?
No.
Why not? Roman.
Well, first of all, root 2 is irrational.
Root 2 is irrational. Could you do 1 divided by the root of 2? No, because what will happen to this number if you guys do what you want to do to root 2, which is go to your calculator and go square root 2? It will become 1.4147 blah 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 blah. And when can I stop? Never. So could I ever divide 1 by the root of 2? No. So the nature of radicals is such that denominators must be rational. All right? Is everybody cool with that? Now, you are intelligent young people. When you see something in math that you don't like, and don't write this down, just use your brain, x plus 3 equals 7. When you see something you don't like in math, what do you do to get rid of it? You do the opposite of what you see, yes? All right. So here I have something in math that I do not like. So what must I do? I must multiply it. I must do the opposite of what I see. I see the square root of 2. How do I get rid of a square root? I square it. So I would have to multiply this by itself, yes? Now, you are all aware of how fractions work, yes? What is this value right here? Why? Because I multiplied the denominator by 2, which means I must multiply the numerator by the same thing, or I will not be equal, yes? So if I multiplied this denominator by root 2, what must I multiply the numerator by? Root 2. Now you are still intelligent young people as you were 2 seconds ago. Same thing in the numerator as the denominator. What is that value? 1. Does multiplying by 1 ever change a value? No. If I have a $10 bill in my pocket and I multiply it by 1, I still have $10, yes? So this is not changing the value of 1 over root 2, is it? But is it going to change what it looks like? Yes, because when we multiply, what is 1 times root 2? I should hear 30 people. Root 2 over, what is root 2 times root 2? Technically, it is root 4, which is 2. Now, do I have a rational number on the bottom?
Yes.
Now we are okay. Does everybody understand? Okay? We are not, it is impossible to divide by an irrational number. Okay? Everybody good? Aditi. Pardon me? The numerator can stay irrational. Right? Because whatever that is, even out to infinity, we can cut it in half. Every one of those decimal points can be divided by 2. And then this answer would just go on to infinity again. Okay? Now, this, is really quite easy to understand, isn't it? Right? You got something there you don't like, you do the opposite of what you see, yeah? All right. Now, cast your minds back. Remember yesterday when we were talking about multiplying, we did those couple of questions where the middle term disappeared. Do you remember that? I told you yesterday to keep it in your head. This is what they looked like. Again, don't write it down, but it was something like this. 6 root 5 plus 3 root 2, and then it was the exact same thing, but it was minus 3 root 2, yeah? And it dropped out, right? And all that mattered was that and that, right? Now, you're intelligent young people. When I multiply the root of 5 by the root of 5, the square root's going to disappear, isn't it? When I multiply the root of 2 by the root of 2, the square root's going to disappear, isn't it? And the numbers in the middle are going to disappear because we know about the plus and the minus, yes? This is how we get rid of radicals that look like this. Because we aren't allowed radicals in the denominator, and we cannot add these because they're 5 and 2, so we still have to get rid of them. So we know we're going to multiply by 6 root 5 to get rid of that root 5. And we know we're going to multiply by 3 root 2 to get rid of that root 2. But if I do plus, nothing drops out of the middle. Right? If I do minus, stuff drops out of the middle. And this is what we call the conjugate. Now, you don't need to write that down, because right over here, I have what is the conjugate of the following radicals. So a conjugate is the same expression with the opposite operation. I forgot the I there. I said operaton. That's okay. So what is this guy, what is his conjugate going to be? Ethan. 3 root 14. Abso-smurfly correct. What is this one? Root 34 minus 4 root 2. What's this one? Now this is where it gets tricky.
1 over root 5.
No. It's just root 5. Because we're trying to get rid of the root, right? And to make it so it's the same, root 5 plus 0 would just be root 5, wouldn't it? And this would be root 5 minus 0, which would still be root 5. Is everybody good? All right, so to recap in this blank stuff at the bottom, root x over root y. Wait a minute. A, B. These are the paths you can take. A divided by B, root x, oh, sorry, that should have been an x. Sorry. Root x divided by y. That's one thing. If it all works out perfectly, that's if everything perfectly divides. The next root you could take, a divided by b, x divided by y, and you might end up with a fraction root x divided by y. And that is when a divided by b doesn't work. Right? We simplify the fraction. I have m and n because they would be different numbers if we simplified the fraction, yes? Third option, a divided by b, and remember, it might be one of the other two, root x divided by y, and you end up with a root y on the bottom. And we multiply by root y over root y. And the last option, I have a divided by b, root x over root y plus root m. Then I got to multiply by root y minus root m, root y minus root m. It's the only four things that can happen, but they're all essentially the same thing, yes? Now I know that teenagers have trouble dealing with the abstract, like putting A's and B's and X's and Y's. Whoa, if I put numbers there, you're fine. So, of course, we're going to do this with numbers right now. All right? I'm going to let you take a moment, gather your thoughts, finish writing that down, and we'll move forward. Are we good? You know we're about to do all four of these, right? You'll be doing it with real numbers if you don't want to write that down. Oh, crap. I didn't say the word. This is this. Root x, x over root y times root y over root y. That is rationalizing the denominator because you're taking that irrational, multiplying it by root y and getting a rational number there. That's the word for it. It's called rationalizing the denominator. Okay? Everybody good? All right, so let's look at this first one. So we already know that it's like multiplying. Coefficients go with coefficients, radicands go with radicands. Will 2 and 3 divide? No. Will it simplify? No. So it's done. 2/3. Excellent. Do 6 and 7 divide. Do they simplify? So there's nothing we can do there, yes? So we look at that and we say to ourselves, self, I am not allowed that there. So I need to get rid of it. What is bothering us? A root 7. That's what I have to get rid of. So I know I'm allowed to multiply by 1 because that doesn't change any values. And I want to get rid of the root 7. So I multiply by root 7. Now I have 2 root 42 over 3 times 7. Because root 7 times root 7 is 7, yes? So I have 2 root 42 over 21. Is everybody good? And there I stop because 2 and 21 will not get any simpler. Good? Now notice something. I did not bother bringing the 3 to this party, did I? Because if I bring that 3 there and I bring that 3 there, they're just going to cancel out at the end, aren't they? So I don't need to bring them along. If I did bring them along, I would have had 6 over 9, right? Which I would simplify anyway. Okay? So let's look at this one. What's going to happen with 7 and 14? And what do you get? You get 1 over 2 root 5 over root 6, yes? What there bothers you? Root 6. Does the 2 bother you? No. So we don't need to worry about getting rid of the 2. But we do need to worry about getting rid of the root 6. What do I do to get rid of root 6? You rationalize the denominator by multiplying by 1. But that 1 has to be written as what? Root 6 over root 6. And what do I get? I get 1 root 30, which I would never write, right? We wouldn't write the 1, but that's cool, over 2 root 36. What is root 36? So I have root 30 over 12. Now, does root 30 simplify? No, because it's 2 times 3 times 5, no pairs, and I'm done. Everybody cool? What if root 30 simplified? What if this number simplified? We would do it, which would bring an coefficient out here, yes? Then what would happen if that coefficient worked with 12? Then we would fix it up. Everybody follow me? All right, so let's try a couple where that indeed happens. So here we are. 6 and 5 doesn't work. 50 and 18 don't work. We're done, right? Of course not. I got to get rid of that root 18. Now, does it make sense to multiply by root 18 over root 18? I wouldn't. Because 50 times 18 is a big number. What should I do first? Simplify. Why do we simplify first? Because it makes things simpler. This is, of course, 25 times 2. So this is really 30 root 2, isn't it? Yeah. Over, what's this one? 15 root 2. And now, look how easy it is. 30 divided by 15? 2. Root 2 over root 2?
1.
1. Do we write 1?
No.
Done. That's the answer. We didn't even need to rationalize, although it looked like we needed to rationalize. If we didn't simplify, then we're doing a whole bunch of extra work. Right? So what are you going to do with D first? You're going to simplify. What is 60? I would use 4 and 15 myself. Why? It's a square. So that would give me what? 15 over, what's this? 9 and 3, so that would give me?
6 over 3. I mean 6 root 3.
What do the 6's do? Cancel. Do 15 and 3 work together all of a sudden?
Yes.
To get what? Root 5. And I never needed to rationalize. Everybody cool? You don't always have to rationalize if you simplify and find out that it's going to work. Is everybody good? All right. Now, this drives me batty. Nobody put your pen to your paper for a second. I'm going to do something here that I would bet at least 10 of you want to do right now. Is that okay? No, it is not. Ever. Don't do it. Stop. Is this okay?
Yep.
Yes. Because this 1 is root 3 over root 3. All of you, even though I'm making a big deal out of it right now, at some point this year, you are going to do that and tell me the answer is 6 root 2. You are going to do it. And then you're going to do it again in grade 11. If you're in my pre-calc 11 class, you're going to do it again. If you're in Mr. DeVries' IB year 1 class, you're going to do it again. And we're both going to do this. And it's going to hurt our feelings. Don't hurt our feelings. All right? So, what should we do with that? What there isn't allowed to occur? The root 3 in the denominator, yes? So how would I get rid of that, Roman?
Root U times it by root 3 in the numerator and the denominator.
And now we have to remember yesterday, don't we? Because yesterday, now we're distributing, aren't we? So what do I have as a new numerator? He waited patiently. 6 root 6. Root 9. Because it's 3 times 3. Over what? Root 9. That's what is really happening, yes? Now, some of you in your head might just write that as 3 and 3 right now. Is that okay? Which is it, Mia? Yes or no? Is it okay?
I'm gonna let you finish.
Oh, I see. Of course it's okay. You want to write that as 3 and 3, go ahead. But as the teacher, I'm showing you what is actually happening, so nobody can say, you never showed us that. Because even though I now keep video of everything I showed you, my students still have the nerve to say, you never showed us that. And I say, oh, didn't I? Click, 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 and there it is. So this is, of course, 6 root 6 minus 3 over 3. Now, if you left it like that, I would give you, if we were doing the way that people want you guys to be marked now, which is on the 1, 2, 3, 4 scale, minimally meets expectations, or approaching expectations, minimally meeting expectations, meets expectations, and exceeds expectations. For me, if you got there, that would be, if I was feeling charitable, that would be a 3 on that 4-point scale because you have met my expectations. Now, in actuality, of course, it is not. That's actually a 2. Because in math class, to meet expectations, should you not simplify completely? So if you simplified that completely, it would be 6 root 6 over 3 minus 3 over 3, which would be 2 root 6 minus 1. Now, unfortunately, that is as far as you can go, yes? And in math, do we not expect you to simplify as far as you can go? Yes. So is that 4-point scale useful in math class? No, because how do you exceed my mathematical expectations? If the expectation is to simplify as much as you can, how could you ever get the 4 that is available to you on those stupid rubric scales? Could you ever get it? No. And yet that's how they want us to mark you. So what do? I make, when it's something like this, where you could stop there and you're like, phew, I'm done. I am charitable. I will give you a 3 there, and I would give a 4 to the kid that goes all the way through as far as they can. Every time. Ethan.
What's the operation for the last, that you have
3 divided by 3 is 1.
Okay.
6 divided by 3 is 2. Everybody cool? Right? Okay. So whoa there, big shooter. You should be able to do number F. You should be able to do letter F by yourselves right now. Tricky, remember, do you need to care about that too? When you're rationalizing? No, but you need it there when you do the multiplication. Everybody try this, go. I would highly recommend trying it in pencil because it's the first time you're trying it on your own without me. If you were one of those people that didn't listen to Mrs. Bad Crumble the entirety of the time you were in kindergarten, all the way up to grade 7, and you were still doing math in pen, I have no sympathy for you. Because I know for a fact every math teacher you have ever had said do your math in pencil, including this one. Damn, that's hot. Now that you've had a few minutes to start, I will remind you of the most important... Damn it! Guess we're not getting those quiz marks today from the last one or today's, and we're not finishing this. Your homework tonight, do F, G, and H. 3 questions. Please notice, G and H. Oh,